Well, good afternoon. Coming to you live from beautiful Buell, Idaho, with my working partner here, Josephine the Wonder Kitty here. We're going to show you how to build a robot, a small desktop robot, which will serve as both three times. Well, it'll serve as three things. It will serve as a robot. It will serve as a power outlet. It will serve as a USB charging station, and it will serve as a lamp. So it's four things. So I'm going to show you what we use. First off, as you can tell from my workshop here, I have a certain style when it comes to putting things together. And what I do is I surround myself with everything I find, and then I look at any given moment and see what I can see within the configuration of stuff that I have found. As an example, I will give you, well, I'll show you some examples close up. Well, you can start a robot project from any place you want. You can start from being inspired by a robot you've seen in a movie. You can be inspired by a robot you've met in real life, however you want to put it. But when I build robots, I start with like one piece. Now here's an example. Here I found, okay, this is part of the head. I found a lamp. I took the lamp apart, and when I was left with his head. So I thought, okay, this is part of his head, and I will show you as we go. Forget explaining, we'll show you as we go. Another thing we'll do is his body. Body was based on the fact that I started with these devices. Got a bunch at a Deseret outlet called the USB wall socket. And what these are is a universal 110 220 volt outlet. It's a plug outlet that has both the regular US outlets on here, and it has 5 volt USB outlets. And in the USA you can pick these up for a standard socket. It'll cost you about $20. Not terribly expensive. I got a bunch of these at $2 a piece. Some of them are broken, and they don't fit a standard American USA type of outlet box. So that was a big thing, is I had to custom make a robot box that would fit this particular outlet. Now along with that, once we start with one thing, that leads you to the next thing, and everything has to start from someplace and then expand from there. So I started with this, and I found a metal box. I found a metal body box that had a solid body that I could then cut to fit. So I cut that to fit, and that fits directly, it fits perfectly when I cut it into this box. So now I have the body, in essence the body of the robot. And I already have the head, I showed you the head. So now I've got the body and the head. Now I'll show you how I go along to create the next steps, the legs, the arms, whatever. So example is, I'm going to kind of show you here, you'll look over my shoulder. So we have the box. We have this box, and we have this plastic thing here. And we have the head here. Now the box I had before was a similar box. It was it had a single metal plate here. Notice this has holes. This is for punch outs when you're doing electrical work. This was harder to work with. I managed to find a box, and I didn't take a picture before I cut it apart, but this box had a simple solid plate. I had a solid piece of metal here. I'll give you a comparison what it kind of looks like when you have this. Now you can get a cap. These metal plates can be used to seal off boxes. Anyway, point being is that this had a solid back. But the solid back, I wanted to be able to fit this in here, and so I cut. It's kind of a good idea for a template. The cutout hole for this, and I used a grinder to cut the opening out here so that this would go into the exact hole. So this lines up. This is how it mounts inside. Now, this is a lot of extra work, but I had to do it just because I was using an item I already had versus buying the appropriate American style. We got our box, got our robot. We can mount this, and we'll use this. That's our part. Second area this is the head. Head is simply a standard ceramic socket. I will show you in a minute how I create the neck for this, but we've got that there. Okay, we have this nice little head. We have this neck. Now we could use this and create a neck and have them just, sitting up on the metal. So in essence, you'd have a neck. Looks okay. Make a direct, direct neck, but I don't like that. I want him to have a neck, and I'm thinking I got two options here. I have some metal conduit that I could use for a neck, and I've got some plastic tubing, which is part of an old air hose, which I could also use for a neck. Now, the trick or the problem is that you'll have certain spacing. You'll have this diameter here, and you go like, oh, will this fit? Can I make that fit inside that? And conversely, we can see that the plastic's got plenty of room. I can easily make that fit. For looks, metal might be really, really nice. Because of the insulation here, you'll notice this has fabric insulation. So if I use metal, there's no danger because this is grounded. This is all grounded. The wires are covered. And if you look inside, so you're not going to possibly get hurt if you use metal because this is all grounded. This would be part of the same thing. But plastic might be better. Just from an absolute perfectly safe safety standard, plastic's probably the most safe. Although metal would be, it'd still be safe. Well, I'm going to try a few things, and we'll see if I can show you how it looks like when I'm done here. Okay, so by trying this out, I discovered that if you look, this thing focus, it won't fit. It's not nice enough. It's going to give me. It's not going to work with the metal, so I'm gonna have to go with the plastic. So the plastic will fit. It will fit well. It's nice. Also, it will leave us a little bit of leave us an industrial look when you're done with it. So it'll be safe. It will look cool, and it will all work out well. So we're going to go with just the plastic. Now, it could have been that either the plastic or the metal would have worked mechanically, and then we'd have to be a question of aesthetics, where we go, gosh, do we make the choice? Which looks better? And that is part of the challenge, is as you go along, as you'll determine the aesthetics may come together differently than you had intended, but it may or may not look. When you get it done, you may or may not be as happy with it, but this will be a good look. I like the plastic look and the ceramic, and okay, we're going to start with this and go to the next phase. I've already got the idea for feet. So the feet are really pretty easy. The feet are simply going to be, these are pipe flanges. So we know the pipe flange is going to be the feet, and there are various attachments you can use when you use pipe flanges as the templates for feet. So, but you have a kind of proportion to start with. So I'm going to use a solid metal leg. I could also use a flexible leg. I mean, I have flexible stuff. I have thin stuff. That might be kind of cute to do really, really, really skinny legs. I could do that. I got fatter conduit. I've done various things. But for this one, we're just going to use straight pipe. We're going to use pipe legs and these kind of pieces. So the pipe will fit as a slip joint into here. So the trick will be to determine how long is his leg going to be. Now, we could have a really long-legged robot if we wanted to, or a short leg, but what I'm going to do, I'm going to base mine on a proportion of your standard metal box is about 4 inches square. It's a standard dimension or close enough to it. And once we know the proportions, every box is proportioned at 4 inches. If I make the entire leg, including the feet, the same length as the box, that tends to work out really, really well. Like, I'm going to give you a little visual here. If the leg were the same length, I'm kind of behind the back here. Now you see that the leg is this long. So let's say if the leg is the same length as the box, if we start here, move this up here. See, now we know that's about similar to human proportions. The upper torso is about the same dimensions as the upper torso is the same length as the leg. Close enough. And we can try with that. So we'll go ahead and try that. Got my cut-off device here. And watch your fingers. There we go. Roughly the same length. So I'll file it here. I'm going to do a little filing and clean this edge up here. Only files in one direction, like that. Like that. Smooth that off. Smooth that off here. The direction. Feels good. You can be as neat as you want. You should probably be neater than this if you're really giving away a nice present. But again, I'm just showing you, so cut me some slack. So, got the leg. And I happen to have these little pieces. This is interesting. This is a waterproof metal connector. And it's trying various things. But what I like about this is it gives them kind of a... I'll tighten it later, but to give you an idea, there we go. So so there we go. It's like, oh yeah, that's pretty good. One leg, about the same height. It's about proportional to the body. I like it. It kind of looks like he's wearing little short pants here. Again, I could do an inversion of this at the bottom. I could do various kinds of things, but I kind of like that. So he's got short pants and crew socks. So. All right, so let's go ahead and like the other, we'll just cut ahead and do magic of cinematography, go on to the next phase. So now we've got our box cut. Well, my demo box, I'll show you a different one here. We cut here, there's they have these things called punch outs, and these happen to be for a 1/2-inch pipe. So we're gonna flex out the punch out for that, and put this, again, one of these in here, other side. Okay, goes in like that. Joy is always starting these. It's about 40 degrees outside as I'm doing this, so my hands are really hurting here. So we got that. You see? Look, just take this leg, put the leg here, tighten that clamp. Same thing here. Tighten that. And voila! See? Already got the body. See, we're starting to come together. And so here we have the actual box. And we're going to punch out the little feet so we can stand up. And first thing is to make sure we have this thing oriented in the correct dimension. I keep, for some reason, I can't remember which way. Alright, so that's it. So we know this is this bottom, side, top. We're going to punch out, we're going to have this facing so that the USB outlets are on the left and the power outlets are on the right. That's just our convention. So I know that these holes, I'm going to punch out these 2 holes for the legs. So let's do that. And the way that works, I'm simply going to take a screwdriver and a hammer, and we're going to just tap right here. I'll tap, one tap, and this one, you can punch out 2 different size holes here, so I've got to be careful to I want to punch out just the 1/2-inch side, so I'm going to try putting it right there, and I'm going to tap just like that. Perfect. Okay, so that works. And if any of you want to comment and tell me you do not use a screwdriver as a punch, I agree. However, I'm still going to do it. So there you go. I got a screwdriver, it's a punch, it's whatever I need it to be. It's a magic tool. You take this, you take your metal box, you bend those back and forth, and voila, one down, other side. You bend that back and forth. There you go. You got your 2 holes here so that you can now put your feet through. I'll start by putting the feet, or the shorts, putting the shorts on. One side goes there. There we go. One side of the shorts. And then the other side of the shorts. Already have the hole punched. And cool. So two things, there are his shorts. Sorry, there are his shorts ready to go. And you put the legs in here. Come on. One leg. Tighten that in. Other leg. Tighten that in. And then here. One leg, two leg. And there you go. So what do you think? I'll zoom in there. So there he is. So now he's got two legs, and now we'll move on to the rest of him. Okay, we cut away here because I built the robot, and see, I got his legs and I got his feet, but I took a pause there because when I had the feet, it's a little bent here. Well, you can do it though. When I got his feet, they were just a bit, his feet, it would be kind of knock-kneed, as it were. His feet were too close together. I'll put them on here. And I ground off a little section. So if you look here, there we go. There. So his feet fit nicely like that. I put him a little, see, I ground off, if you see here, I just ground off a little bit of the head of the pipe flanges so that they just fit a little nicer there and allow him to stand flat-footed. There you go. Stand nice and flat on whatever surface he's going to be standing on. Now, later on, as we finish him up, I might do something different with the legs, but we'll get to that when we get to that. Now, one thing, as we've created this little robot who will then become a lamp, is he's not, I mean, he could be stable enough, but, you know, I thought I wanted to make a base that you could then put him on so that he'd be even more stable, and I racked my brain trying to think of various things you could use for base, and you could use all sorts of different things. You could use a book, a box, any sort of framework, but one thing I happen to have several of are old hard drives. You know, these are, this one happens to be, well, it's a Western Digital, pulled from old machines, and you know, I had once a source of like 100 of these, and I should have picked them up even though they're useless because they're heavy metal and they make a fabulous base. If you were to put, you can put various stands on it, but you screw that to the hard drive base and you've got this wonderful, solid, cool looking base. Now the trick is, when you're going to mount this, you need to be able to take this hard drive and modify it to make a base. Now, well, you could do anything. You could glue it on if you wanted to, but what I'm going to do is I'm going to take this apart so that I can hollow it out, and I will then be able to screw this, and I will just demonstrate. I can screw it through here, and I can actually run wires through the base if I needed to make a base. So I'll give you a demonstration on how to pull the drive apart so I can make it into a base. Okay, so what I'm going to do then is I'm going to use this old hard drive case as the base for the robot, and I'm going to turn off Bing and Doris there. So again, we're going to use this hard drive case as the base for the robot. Now there's a hole here which I'm going to enlarge to run the power cord. So I'm going to run it down through the leg into the case. We'll see that later. So, but first to start, just want to get an idea. Now you can measure this thing to fit exactly, or you can eyeball it. I'm going to eyeball it just because that's the kind of guy I am. I'm an eyeballing kind of guy. So you see that, and I guess you can see it. I'm going to use my little marker pen to mark the holes to drill to hold the feet on. Now I could drill all these holes out so this completely holds the feet on, but I found that 2 screws on the outside work just fine. I'm also going to have to drill a hole to mark. Let me lift this off here. I want to be able to drill a hole where the power will go through, so I'm just going to go like this inside. It just as long as I can drill a large enough hole. So you'll see there. So now I can drill holes in this case, which will allow me to mount the robot and run the power cord through his leg and out the wall. Okay, for my power cord for my little robot lamp, I'm just going to use an old computer cord. You know, you get these in the blow-up bins for like a few cents to $1 each, and I'm just going to cut this head off. There you go. Then I'll strip the material off of here. Whoa, cool. I'll strip that off to run into the robot for the lamp. Okay, as I'm filming, working on the little robots inside, you may have noticed I was working with pulling on cords to get an idea, and I have these power cords, and they're not very flexible. And the reason they're not very flexible is because the outside ambient temperature and inside the garage is about the same. Do you see that? Right behind me there is a thermometer. That thermometer is correct. It is a Fahrenheit temperature, not Celsius. Yeah, so right around 20 degrees Fahrenheit makes things not most pleasant. So notice that inside the garage it is a balmy 24 degrees Fahrenheit, so at least it's a little better in here. Now I could be one of those people who have you know, a heater in their garage. That's a luxury that I just don't have at the moment, so I'm gonna have to stick with the cold air. Okay, I had fun when I trimmed the wires, when I removed the housing to clear the wires out for this particular power cord. This power cord is a, I'll say UK European. The coloring codes for these wires are different from the American wires. In America, here's like an outlet that's actually wired correctly. America, you use black is hot. Black is where your power comes from. Your white is your neutral line on your AC, and green is ground. So, and if you ever have one of these outlets, the longer slot, this is a 20 amp outlet, so it's got the longer horizontal, but the vertical slot, the longer slot side is actually your neutral, and your black is your hot. Now, you look and you get this cord. If you get an American power cord, you would also see a black and a white and a green power. Same kind of wiring is like this. In fact, I have, if I can find it here. Here we go. Here's a piece of conduit with the correct wires coming out. You got black, white, and green. That's the American standard. Black again is hot. White is neutral, green is ground. European color codes, you're like, okay, brown, blue, and green and yellow. So you might go like, okay, well, green and yellow, that at least I can figure this is ground. But as for this, brown and blue, which is the hot? Those of you who know already know, but in America, if you have a 3-phase electricity, black is hot, and in America, if you have a red wire, the red wire is also usually a hot wire. It's the 2nd phase. The 3rd phase hot wire in the USA is blue. So you might be tempted to think, okay, so the blue in the UK or European is hot. The blue is not the hot. The brown is the hot wire in the UK or European. Brown is hot, blue is neutral, green is ground. The way I remember it is if you don't remember which wire is the hot wire, you're going to be in deep doo-doo. Okay, so deep doo-doo. Brown is hot. So brown will save your life. If you know that brown is hot, then you will save your life because brown is deep doo-doo. So there you go. Hot wire, neutral wire, ground wire. So we can round. So this, we would attach the brown to the black. We would attach the blue to the white. We will attach the green, yellow to the green wire. So there you go. How to stay alive with electricity. Okay, I've used a step drill to enlarge the hole in my metal base. It's not perfect because unfortunately the step drills tend to move around a bit when they already have an existing hole, but it does allow us to run these wires right directly through the case so that when we create the socket later on, we'll have a lovely, we won't be able to see the power cord out the back of the robot, which makes for a pretty look. So it will come through the hole like this, and therefore, there you go. So when we wire the base, it'll be something like this, and you'll just see it from the front. So look, voila, no wires. Well, nothing too obvious once we get it all done, which we'll get to shortly. So there you go. I have drilled the holes, the hole for the wire to go through. I've drilled the holes for the screws to hold the robot's feet onto this base here. So you can just thread them in. It'll look nice when we do it. Okay, I will bolt the robot's feet on. So, all right, we've got the feet bolted onto the base, and again, you could put all 3 screws in if you want. It holds it on. I will trim these off later on, but that's it. There you go. There's your base. So there we go. We got the body and the feet, the legs. Look pretty good. And you can see I have a glove on one hand and no glove on the other. I took this glove off just so I could hold this up and show these things, but I need to wear both gloves because, as I mentioned before, it's about 25 degrees in here, and my hands, they ache. So your mileage may vary depending on whether you're building this in Siberia or in somewhere in Arizona. So I don't remember where we last left off because my brain's so cold I can't remember anything. So we got the foot, the base of the robot lamp thing. So I keep showing like this, but this is actually the back of the robot. Wait, sorry. This is the robot's back. This is his front because that panel will go through the front. So I'm going to put that like this. Put the wires through. And voila. So here we go. There is the front of the robot. This is the back of the robot. And now I'm going to put him down here. And I'm going to start to assemble the rest of it. I think I mentioned I have a head for him somewhere. Oh, here's his head. So I'm going to build his head. And though I'm going to build his head is I'm going to drill some washers. Going to punch this hole out here. I'll show you. All right. So what we've done, I have taken a fender washer. I have drilled out a fender washer using a step drill that fits the diameter of the lamp post. It's a standard kind of a thing to do. I explain it for the sake of thoroughness. You know how to do this kind of stuff, so I won't give you the blow-by-blow, but I will show you the next phase as we then kind of proportion the neck and head to fit the robot, depending on whatever whim I have when I start putting it together. Oh, and I almost forgot. Okay, I've decided to use this plastic flexible tubing. It's just an old like air mattress inflating hose I've sacrificed to the cause. And the way you trim this. You could cut it in any way, but you can use a nice sharp box knife to trim, whatever links you have. And I'm going to do that off camera because I'm not going to try to cut my hand off. I'm not going to give you any advice on what to do except to be very, very careful. And if you cut yourself, don't come complaining to me. My only advice is to be very careful, cut it, make sure your hand is like that far away. The knife is here, see this? See how close my hand is to the blade? Don't let your hand get a whole lot closer than that. Well, maybe like this, and put it on a solid surface. Don't do it in the air, you will slice yourself, you will make a mess. So put it on a solid surface, cut the right length of hosing, and save yourself a lot of pain and suffering. Okay. All right, I cut the plastic to fit, and notice I still have all 5 fingers, four fingers and a thumb, both hands, so that's good. So what I did is I just tightened. Okay, I've got this column that I tightened. This is your standard lamp post type diameter. I think it's 1/8 pipe thread or something like that. So we know about that. So about a neck like that, that's fine. Then all we do is we put this spacer washer here. It's really hard to do this when your hands are gloved. So that will go, already screwed up. I'm going to put a nut on first. I got to take my gloves off to reach in here. So I'm going to put a nut on this side. Oh God, my hands are cold. So I put a nut because I will spin this on here because this will be the height, the length of my neck. So I'm going to spin that on. Spin, 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 spin. About like that. We can mess with this later. So put that on. There's your washer. Now, there's my spacer. See, that goes like that. That way this will then go into the head of the robot like this. See what I'm getting at here? So you get an idea. So now I can just tweak it. I'll decide how long I want the neck to be. I might go like, it looks a little bit maybe a little longer neck than I want. It might be fine. Okay, but the principle, then I will simply nut this on. I will adjust the height of this column until it gets to a height I like, and we'll cut back to that when I do that. Okay, I managed to thread the head in place here. I'll give you a little bit more of a close-up to get an idea. See, I just put the nut on here. We're gonna turn that by hand at 20 when it's 20 degrees outside. But see, I have forgot to put my spacer washer on. Blast it. Okay, I'll be right back in a second here. All right, I put the correct. As you see, there's the fender washer, both sides, and the nut here. That allows us to tighten the neck on, and we'll tweak that again. But see, not bad. So you look at it and you're going, oh, hey, it's starting to look like a little guy here. He's not got any arms yet, but we'll do that. So I'll tighten all these bolts down and then come back to here. Okay, we're back, and you can see he's again looking much more robot-like, much more alive. I think I said something like, tighten all the bolts. It might be a bolt, it might be a screw, fasteners. In the trade or whatever, it's like make sure all the fasteners are tightened. There are the fasteners that hold the pipe pieces in here and the legs. There's little screws that hold these the pipes together. There's screws and bolts and nuts and whatever. You tighten everything as you go to make sure everything is tight. All right, I'm going to go ahead and show you how I'm going to attach the arms. Notice he's missing arms, and I guess you can do whatever you want with arms and the hands, but what I'm going to do is I'm going to create little shoulders for him, and of all the pieces that you can get for your robot out of electrical supplies, this is it. This is it. This is your shoulder boast. This is fascinating. This is made for I believe it's called 3/8" conduit, and the kind, I want to be able to move his arms, so they make these that have little screw-in threaded adapters. This particular device has a it snaps in, and when you snap it in, well, I'll show you. When you snap it in, so this is the front. See, I ripped that hole out. Let's pop that in here. Look at that! Instantly, you've got. Look at that! Isn't that great? Got a little shoulder, and see, when you use these pressure fit kind, you can move it later on. If you have, see, I have these legs screwed in, and they're screwed in with these nuts. And when you do that, it makes for a very nice tight fitting, but you don't want to move it back and forth too much because then the thing will fall apart. But this way, you can, later on, you can, hey, have his arms sticking out or put them down. So these are fabulous. I love these things, and I will actually, let me see. This is the little bag they came in. So this particular device is Arlington Industries 90-degree snap tight connector for 3/8 inch flex AC. So that's what you want to look for. So for those of you who care, the shoulders that I use for my robots are based on a 90-degree snap tight connector for 3/8 inch flex AC. And I think this, what do these cost? Might cost $1.75 a piece. Maybe cheaper if you buy them in bulk, but that's it. The key to the robots is his movable shoulder joint. Legs, we can do a lot with the legs, different things for the legs. But for the arms, I like the shoulder joint and the conduit. We could try some experiments later on, but for now, we'll stick with that. So now you see my little robot has little shoulders, which already make him look much better. Then we're going to make his arms. Notice when I showed you the packaging, it's made for 3/8 inch flex conduit, and this is it. This is great stuff. Now, as for parts cost, as you can tell from all the surroundings, I have a lot of extra leftover pieces from various projects. So I never throw anything away because you never know when you can use it. So I have a roll. I have several rolls of this conduit. So I use the conduit flexible stuff because, well, it works really well, and you don't need a whole lot. If you're going to start, working robots, you're going to have to get yourself a bunch of parts. And now what I'll do then is I'll use this, and you could measure, but I'm going to just kind of use my hand to measure and figure arms are about the length of the body. So I will just eyeball that, and I will cut this piece here to his arms, assuming that the arm goes just about the length of the body, and always make it longer. Measure twice, cut once, or measure once and cut several times, and then have little pieces of random pieces left over. But if you do that this way, well, I'll cut an arm, and you can see how it works. And ta-da! Voila! Look, an arm. Isn't that great? That's one arm, and I like the length. We're gonna leave it because I'm gonna, for the hands. Well, I'll show you really in a second here, but get an idea. All you do for this when you're working with this conduit, you just have these little screws come undone, and you slide the conduit into this little guide, and if you electricians out there know exactly how this is done, it just basically sits in there. There's a little catch that it'll hang up on, and so tighten it in. Voila! So, oops. That one's off a little. Let me expand that out. Gonna see if I can thread this in a little farther. Right about there. All right. And tighten that in. So there you go. There he is. He's got two arms. Now, the fun part is, fun part. It's all fun part. Hands. You think, what could you use for hands? Now, there's lots of things you could use for hands. You could put grippers or clamps, hands are whatever you decide you want to do, but I'll give you a very quick, easy, and very cool hands is to use plugs. These are, now I like the metal look, so I thought, oh, hey, and it happens this diameter here happens to be very, very close to the outside diameter of the conduit. So you can use these for hands, and it looks kind of like pinchers. Again, you can do it whatever you like, but I like these for the hands. And I suppose a person could plug these in if they were really, really stupid. So if you wanted to be really, really safe, and you thought, what if a little kid decided to plug his arms into the holes? By default, these have plastic inserts. There's no way these can be live. So even if you plugged it in, I've cut this off, and I've cut the wires. I left the wires inside, but they don't reach through. If you really, really wanted to be safe, you could take this apart. You could put in a rubber plug or something like that, so that there's, even if you plug these into an outlet, you couldn't possibly hurt yourself. I'll leave it up to you to do that. But I'll put the hands on now and then cut back once I have his little hands in place. And voila, there he is. He's got hands and arms and hands. And also notice he's backward. Well, see, this is really his front. But look how easy it is. I just go like this and, hey, cool. That's it. He's got arms. Ta-da! Now, how cool is that? We've already got it. I mean, look, you're 90% home. There you go. That's your basic framework for any sort of little robot lamp device. Now, with the bodies, these have standard fittings. You can then figure out ways to put things inside of them. You could hook light switches on here. I'll continue on with what I have, and I'll show you how it works. But you can use this kind of a template for anything, and so this is it. This is like 90% there, but we'll continue on to show you the rest of what we could be doing here. All right, what we've done now is I have mounted his, this is the USB outlet, the European model, which I mounted onto his the chest plate. I've pre-wired the wires to the back, and I'm going to put this switch onto the back of this assembly here. And one of the things that I will remark that I've done here is that I have used flexible stranded wire for my connections. I've tinned the ends with solder so it makes them easier to hold, and I will use some instead of using wire nuts, I'll use these connectors. But you can always use solid wire. And usually in walls, or if you actually use these kind of boxes, most of the time they use solid wire. It's really difficult to work with solid wire in these really, really tight places. So stranding just makes it easier. And the load on this thing is very, very, very light. You don't need to have a whole lot of current. So we don't need to use solid, heavy-duty wire. We can use, this is, even the wire coming out of here, the power plug is, I think, probably 14 gauge. No, 16 gauge, probably 16, maybe even 18. Point being is that we're going to use stranded wire just to make it easier, and so our hands, we don't hurt ourselves trying to push things into tight places. So a little bit more on that as I show these wire nuts. And when we make the connections inside, I'm going to use, this is a Wago. There's a brand of a connector for doing splicing wires together. It's called a Wago. Wago makes a brand. I got these and they were labeled as Wago when I ordered them, but I can't be sure if they came from an overseas country. That it's possible that these are bogus Wago connectors, but I do have a box of genuine Wagos. But for this kind of situation, it's plastic with metal. Even if these weren't genuine, I'm not going to damage anything by using these. So we're going to use Wago connectors, Wago brand name connectors for hooking all the wires up. Okay, he is wired for a light and wired for a light switch. And I'll plug him in here. You can see the plug where it plugs in. Yeah, and then here's the switch. The switch for the light is on and off, on, off, on, and off. And I check the outlets. I check the plugs on everything on the front end to make sure that all worked beforehand. As you can see there, I'll kind of zoom in and talk. These are the Wago connectors. Those are those, rather than using wire nuts, those are really cool because they allow you to clip and unclip the wires. Again, I used stranded wire, so it's quite flexible, so I can move the wires. It makes it easier to push everything inside of the box, inside of the body of the robot, to make for a very neat finish. So I will go ahead and button him up now and then show you what he looks like from the front. I would have loved to be able to really zoom in and give you a lot more details as I went, but it is frickin' freezing out here. It is so cold. I am wearing several layers. It's about less than 20 degrees Fahrenheit, and I've had to do this in phases. But I'll button him up, and then I'll give you a demonstration of how he looks when he's all really buttoned up. So there he is, everybody. He's a little robot. Put my face in the picture here. As you can see, he's got little arms, he's got little legs, and got a switch on the back. I'll show you how that looks. Kind of cool. See? It's got a big box. Big switch on the back. And got these little chargers here. There's this plate that mounts here on the front. That this is a snap. This is a snap. See, this is the universal European style outlet. What it has is you can put in 220 volts AC, 110 volts AC, and it converts down here. It converts it to 5 volt standard USB. The outlet voltage would be whatever the mains voltage is in your country. This has a faceplate that has the American USA type click on it. So we're just going to click that together. Come on. Click, click, click. Is that it? No, I guess that's it. Cool. So there you go. So there's his faceplate. Gonna plug him back in. When you're working with electricity, unplug everything before you work on it. So now that it's safe, you can turn him back on. He works. And voila, you've got yourself a little robot. So in conclusion, you too could build a robot. This robot, it's a robot, it's a lamp, it's a charging station, it's a power outlet. You can find the parts. There are many parts that you might have around your house that you could repurpose into a robot. You may have to buy things yourself. I guess my thing, where I'm coming from, is that if you look around, you can find shapes. You find shapes, you can repurpose them any way you like. So the long and short of it is that in return for a few hours spent out in the freezing cold, you can get yourself a little robot using things found around the house. A couple of things I will just mention is that, again, it's helpful if it's not really cold in your workspace. I don't have a heater at the moment, so I'm just freezing my buns off. Again, if you have random parts are helpful. I happen to have when I was working on my materials, I had several cordless drills, and I found out that the lithium ion drill would keep dying on me. The nickel cadmium drills would stay working in the cold much longer. Also, the camera I am filming this with is a lovely little Olympus camera which has great high definition video, but in this cold weather, the batteries last about 10 minutes, so I'm constantly swapping out batteries. So it makes it for more of an interesting project. Anyway, I hope this has been somewhat entertaining, if not informational, educational, and good luck to you. And if you build your own robot, I'd love to see pictures or videos. Send me the link. Thanks.